colleagues, this is advanced digital filtering in case of proliferative diabetic retinal disease. This is a long-standing hemophthalmos, and behind it I anticipate to find, let's say, advanced proliferative diabetic retinal case. I'm using here 579 nanometers digital filter, which highlights the vitreous better, and that is why the blood color is a bit different, but you will find that the details which I'm seeing are highlighted. I'm using chandelier and I prefer to use a self-indentation. In diabetic cases, I prefer to dissect first the peripheral vitreous and then gradually to advance to the posterior pole in order to be more precise and safe during the removal of the diabetic membranes. Here is the peripheral trimming of the vitreous, which is stained with the blood. And now I will go to the center. Now you can see a massive proliferative membrane from the optic nerve. This is the plane or the normal view, and this is autofluorescence of the same membrane, highlighting the fibrotic tissue and the peripheral blood-covered retina. I will use my vitrectomy with mild vacuum and cutting to gently approach this membrane in order to slowly remove it from the optic nerve. Now you can see how I can approach the fibrotic tissue only and gently to pull this membrane in order to see the level of the attachment and how to proceed with removing. So gentle cutting and pulling. You can see that the membrane is step by step freed from the attachment over the optic nerve, and now I will switch to another filter in order to better visualize the underlying retinal tissue and the membrane. This is ILM enhancement filter. So first we need to cut and then to dissect the membrane. I will switch to bimanual approach. I will use the vitrectomy vacuum to hold the membrane, and with a fairly unique scissor from Dork with oval tips and curved jaws, because you can use it as a delaminating spatula, and in the same time you can use it as a scissor. I find it quite useful in diabetic cases, and I do believe that bimanual approach is giving me more precise control and less iatrogenic damage to the retina, which I can cause during the removal of the membrane. So, and then the membrane will be eaten with the cutter. Now, next step here would be intraoperative fluorescein angioscopy, which is done by Ngenuity and with a digital filter only, without any hardware barrier filter used. So I use a proprietary digital filter recipe created by me. You can see now that I can utilize the intraoperative fluorescein angioscopy as a guidance or navigation, because I see where I have leaking vessels in the moment. Here they are. And I will use, of course, diathermy in order to stop the bleeding. So now the Ngenuity is becoming a navigational surgical tool, not only a visualization system. So it will provide me with more precise diathermy and less post-operative bleeding. You can appreciate the leakage around the optic nerve and macula. You can see the membrane. This is the retracted ILM, the perfusion of the vessels, and underlying laser spots also. Now, next thing to see is selective laser. Under fluoroscopic view, I will laser only the ischemic areas, and I will spare the remnant retina, which is still functional, something that we cannot actually do without fluoroscopic visualization. So another navigational application for the Ngenuity, and this is how we can do more precise work, and we can preserve more functional retina in this already damaged diabetic eye. So you can see the non-perfusion or the ischemic areas and where the laser is applied. So here is the functional result of the selective laser, and this is IOM enhancement filter, which I'm utilizing during the peeling. The visualization is done by a biome with high resolution 60 diopter lens, and I'm using Eckert and gripping forceps, which provides me with great control. I'm using a pinch and peel technique, and you can see how the stained ILM is removed in order to relax the retracted macula, and this is how I do believe that the digital visualization can facilitate better and more precise surgical approach in proliferative diabetic retinal disease. Now, of course, I will remove completely the retracted ILM. You can see how the optic nerve is freed. And this is the removal of the ILM. And this is the fluid air exchange. The beneficial thing of the ILM filter under fluid air exchange is that there are less reflections. And we can see better the fluid that we are removing. And thank you for your attention.